Reinforced concrete is a combination of adequate reinforcement and concrete design to work together to resist applied loads. If you properly place reinforcement in concrete, it will improve its compressive and tensile strength. Plain concrete: the concrete may experience microcracking which can progress to visible crack. Cracking is more likely to occur in areas where tensile stress are prevalent. Reinforced concrete: the steel concrete helps control the development and propagation of cracking in the concrete. Reinforced concrete structure can carry heavier load and span longer distance compared to plain concrete structure.
Reinforcement position. To help achieve a strong bond, the reinforcement should be clean, free from flaky rust, dirt, or grease. The concrete should be properly compact around the reinforcement bars. Reinforcing bars and mesh should be located so that there is enough room between the bars to place to compact the concrete. To improve the transfer of tensile forces of the steel to the steel, the reinforcement is often anchored by bending the bars, hooking the bars, and lapping the bars. Formwork. Forms are molds to receive concrete in its plastic form. Formwork is a temporary structure, as such it is not normally shown on the drawings. Formwork are made of wood, plywood, aluminum, steel, and plastics.
Concrete properties. Compressive normal concrete is high. Reinforced concrete very high. Tensile strength very low. For normal concrete very low. Reinforced concrete very high. Shear strength for normal concrete very low and reinforced concrete very high. Steel properties. Steel is a main construction material and is also used as a connection, link, and base plate. Since it has high tensile strength, steel is used in reinforced concrete and pre-stressed concrete. Steel can be obtained in solid, plate, or hollow form. The types of steel reinforcement can be categorized into hot-rolled restoration. The type of steel reinforcement can be categorized into hot-rolled, pre-stressing, cold-rolled, and mild reinforcing bar.
So the advantages of steel is they have the most versatile building materials because it can be used for many residential, commercial, and industrial construction application. And the second point is they have a strong and durable. Steel is very extremely strong and durable because it's making it the ideal material for construction buildings and other structures. It is also resistance to fire, wind, and earthquakes. And the third one is easy to work with. So steel is relatively easy to work with because it makes a popular choice for construction projects. It can be cut, drilled, and welded into various shapes and sizes. And the fourth, friendly environment, because steel can be recycled or used after its initial use. And lastly, affordable. Steel is affordable building materials because it can making it a cost effective choice for construction projects. The disadvantages of steel, they're gonna be high initial costs because steel is typically more expensive than other construction materials such as concrete or wood. As a result, constructing a building with steel can be quite costly. Secondly, requires more maintenance because steel is susceptible to rust and corrosion, and as a result must be regularly inspected and repaired to prevent structural damage. Other than that, Steel is heavier than other materials such as concrete or wood. This can make transportation and installation more difficult and expensive. Plus, the extra weight can put additional stress on the foundation of the building. Besides, steel is not eco-friendly because steel production emits a large amount of carbon dioxide into the atmosphere, contributing to climate change. Lastly, susceptible to fire damage. Because steel buildings are also susceptible to fire damage, while steel is extremely strong, it can melt when exposed to high temperature, which can cause the collapse of a building.